getting away from angles a little bit. This was near the end of that last section we were just on at Inventum on the segments and circles. So again, segments that intersect a circle, you either have a secant. This is a secant when it goes through here and it intersects the circle twice. On the next slide, you'll see when a tangent only intersects the circle once. So I did kind of like the way that Adventum did this. I think they did a pretty good job of it, but it's still just something that I think sometimes the math of it is a little bit harder. So when two secants are drawn to a circle from the same external point, so they make that angle with the vertex outside of the circle, but we want to try to find the lengths of the secant or pieces of the secant. So we have our algorithm, which is our outside piece times the whole thing equals the other outside piece times the whole thing. So if we use our letters from our example here, or from our definition here, our outside piece is this segment here. That is outside. God, I always do that. And then our whole thing is all the way W plus X. So this is our whole. So we always have to make sure we don't just, it's not like when we had it in the X thing, did this, and it was just this piece times this piece and that piece times that piece. We didn't have to add anything together. This one we will. So if we put it together, our outside piece is W. Our whole thing is W plus X. We have to add those two numbers together, and that's going to equal the outside piece of the other one is Y, and our whole thing here is Y plus Z. So that's the tricky part with when we have our two secants. And again, time to pause your video if you want to try this one by yourself. At least try to set it up by yourself. If you get a little bit tripped up with some of the math, that's fine. You can come back and look at that, but try to at least set up the whole thing by yourself. All right, so on the pen. All right. So I have my outside and my whole thing. Outside and my whole thing. So here, I'm going to go ahead before I even set it up and calculate what my whole thing is, because I don't want to get messed up and say, okay, well, it's x minus 1 times 2x plus 1. My whole thing here is x minus 1 plus 2x plus 1. And the minus 1 and the plus 1 actually become 0. So I have x plus 2x. My whole thing here is just 3x. And my whole thing down here is 18. So that is my first step I like to do, is set up what those values are. So that whole thing there is 3x. So going back to my algorithm of outside whole, where this top one, my outside piece is, I'm going to start up here, x minus 1. And again, my whole thing, if I add these two together, is 3x. And for this bottom one, my outside is 7, and my whole thing is 18. So we have to remember to do the whole and not just outside, inside, outside, inside. Do outside times whole thing. So we have to multiply this 3x times each of those. Distribute the 3x to both of those. This becomes 3x squared minus 3x equals 126. If you've gotten that far, awesome. This is where sometimes some of these can get a little tricky because it's been a while since you have been in Algebra 1. So in order to solve this, since we do have an x and an x, we can't combine those because this is an x squared and that one's an x. We're going to bring the 126 to the other side. So we have 3x squared minus 3x minus 126. It still equals something. It doesn't just go away. It equals 0. We're left with nothing on the other side. 0 the hero. All of you Miss Fay kindergarten kids. So from here, in order to solve it, we do have to go back to our Algebra 1 factoring rules. These are big numbers. Always step 1 is see if you have a greatest common factor. And you do, you can factor a 3 out of all of those with x squared minus x minus 42. Now we have to factor this guy. We need the two factors of 42 that are going to add up to -1. We know x and x. We're going to have a plus and a minus because that's negative. And 42 breaks into 6 times 7. And we want the bigger number to be negative because our middle term is negative x. So we're going to say minus 7 plus 6. You can always check it by refoiling first, outer, inner, last, and you will come back up with this. This still equals 0. You do have that 3 out here, but we're going to get rid of that in a minute. In order to solve this, we use our zero product property from Algebra 1. We say, well, x plus 6 could equal 0, or x minus 7 would equal 0. In order to equal 0, at least one of the factors has to be equal to 0. We get x equals -6, or x equals 7. This is where the geometry comes in. We can't have negative distances in geometry. A segment can't be -6. So that one goes away, and our answer is x equals 7. So that is when we bring our good old algebra skills back into geometry. All maths go together. This will be very important for all of you going to Algebra 2 or FADA next year. You will be doing a lot of factoring. One of my favorite things to do. So that was that one. And my last, could throw a little pun in there, my last segment of the day, but we are going to do our secant and tangent. So Again, a tangent intersects the circle at one point, where our secant intersects a circle at 2 points. So this one's very similar, but since for the tangent we don't have an outside and a hole, they're actually both the same thing because the outside is the whole thing. So we do still have outside times hole for the secant part. And it just equals the tangent, and you square it because it would be the tangent times itself, and anything times itself is the same thing as squared. So again, for here, it would be E times E plus F for the secant part, and that would equal G squared. So that is our formula for that one. So again, if you want to pause your video and try this one again, at least try to set it up by yourself, and then you can come back if you need help with the math part. But set it up, do your best, try it out, and then come back and replay the video to see how I do and see if you got the same thing I did. So for this one, we know this outside and hole is going to be the same. Our outside for here is x minus 1, but our whole thing is x minus 1 plus 5. So 5 minus 1 is 4. So this whole thing is x plus 4. So I'm going to mark off a pretty big space for this one because there is some math. So my outside times whole would be x minus 1 times x plus 4. That equals x plus 1 squared. Now we have to math this out. If you got this far, good. At least you set it up right. That's the geometry part. Now here's our algebra part. If you have two binomials multiplying by each other, you can do what they call double distribute, or we have our acronym of FOIL. We do our first two terms. X times x is x squared. Our outer terms, x times positive 4 is 4x. Our inner terms, which is negative 1 times x, which is negative x. And then our last terms, negative 1 times positive 4 is negative 4. Then you combine your two middle terms. We have x squared plus 3x minus 4. Now let's do the other one. This is where every year I have so many kids that are like, okay, x plus 1 squared, I just square the x and I square the 1. But that's not what this is. Anytime you have something squared, you're squaring the entire thing. So this is x plus 1 times x plus 1. Whole thing is times itself, not just each individual thing. Very different. So we have to also FOIL this one. And we get x squared plus 1x plus 1x plus 1. So that equals x squared plus 2x plus 1. Now we just move things around. We can minus x squared from both sides. Woohoo! Those go away. We can minus 2x from both sides. And we're left with just x. So then we want to add 4 to both sides. And x equals 5.